Hi guys, welcome to Miss Igo's classroom. This lesson is about linear and rational equations. A linear equation in one variable is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers and a does not equal 0. Solving an equation in x involves determining all the values of x that result in a true statement when substituted into the original equation. Such values are called the solutions or the roots. So in math, we use different words to mean the same thing. If you're asked to find the solution or if you're asked to find the root, it means the same thing. A solution set is a set of all solutions that satisfy an equation. And equivalent equations are two or more equations that have the same solution set. So the steps to solving a linear equation are as follows. First, simplify the algebraic expression on each side by removing grouping symbols and combining like terms. Then collect all the variables on one side of the equation and all of the numbers or constants on the other side of the equation. Isolate the variable and solve, and then you can check your proposed solution in the original equation. So let's solve and check this linear equation. So the first step that we talked about was to simplify the algebraic expression on each side by removing grouping symbols and combining like terms. Well, there are no grouping symbols and there are no like terms. So the next thing that we want to do is to collect all the variables on one side of the equation and all of the constants on the other side of the equation. So I see that there is a constant on each side of the equation, so I want to get my constants together, and I'm going to do that by subtracting 5 from both sides of the equation. And when I do that, I get 4x equals 24. Then I want to isolate the variable, and I can do that by dividing both sides by 4. And that gives me x equals 6. Okay, so then to check my proposed solution, all I need to do is plug what I got for a solution back into the original equation. Okay, so if I do that, if I plug in 6 right here where the x is, and then simplify both sides, as long as both sides come out to be the same, then I know that it's true. Well, 4 times 6 is 24. And 24 plus 5 is 29. So since both sides equal, then I know that this is a solution to the system, or the equation. Okay, here's another example. So this time we do have grouping symbols. The first thing that we want to do is get rid of the grouping symbols on each side of the equation. So to get rid of the grouping symbols, I need to distribute. I'm going to distribute 4 to both terms in that first set of parentheses. So that gives me 8x plus 4 equals 29. And then I'm going to distribute the 3 to both terms. So that gives me 6x minus 15. Alright, then the next step is to combine any like terms that are already on the same side of the equation. Well, on the left side, there's not any like terms, but on the right side, these two constants would be like terms, so I want to go ahead and combine those. Alright, so this stays the same. And then if I combine positive 29 and negative 15, that's going to give me a positive 14 plus 6x. Okay, so now I need to get the x's on one side and the constants on the other side. It really doesn't matter which side the x's end up on. I'm going to subtract 6x from both sides. Alright, so that gives me 2x plus 4 equals 14. Okay, so now I want to try to get the x by itself. I want to isolate the x, so I need to start moving things away from the x. So I'm going to subtract 4 first. and that gives me 2x equals 10. And then I divide both sides by 2, and that leaves me with x equals 5. Okay, I didn't leave myself a lot of room, but if I wanted to check that solution, I would need to plug 5 in every place there's an x in the original equation. Okay, so let me do that. I have 4 times 2 times 5 plus 1 equals 29 plus 3 times 2 times 5 minus 5. Oof. Okay, so if I follow order of operations and I do what's inside the parentheses first, I have 4 times, okay, 2 times 5 is 10 plus 1 is equal to 29 plus 3, and then 2 times 5, that's 10 minus 5. Okay, so 10 plus 1 is 11, so that's 4 times 11. And 29 plus 3 times 10 minus 5 is 5. Okay, so that's 44 is equal to 29 plus 15. And 29 plus 15 is 44. So we know that 5 checks out as a solution to our equation. A rational equation is an equation that contains one or more rational expressions. Well, if you'll remember, a rational expression is an expression that's basically a fraction, but we don't call just regular fractions rational expressions. We call it a rational expression when it contains a polynomial in either the numerator or the denominator or both. So if we have fractions that have variables in them, we call those rational expressions. Well, rational expressions or equations are easier to solve when they don't contain fractions. So if we have a rational equation, what we want to do first is to get rid of the fractions. And we can get rid of the fractions by multiplying both sides of the equation by the least common denominator, and that will clear the equation of the fractions. Alright, so here's an example, and it says, or the first thing that we need to do is multiply everything in the equation by the least common denominator. So if we look at all three terms and determine what the least common denominator is, the least common denominator between 4, 14, and 7 would be 28. Okay, so if you don't remember how to get a least common denominator, if we have just numbers, look at the largest denominator first. So 14 would be the largest denominator, and we want to see if the other two terms can divide into that number. Well, 7 can divide into 14 evenly, but 4 cannot. So we take that largest denominator and double it. If I double it, I get 28. Alright, so then we look at the other two denominators. 7 can divide into 28, and 4 can also divide into 28. So we know that 28 is the least common denominator. If the other terms couldn't go into 28, then we would need to triple it. We need to multiply 14 times 3, and then see if the other two terms would go into it. Whatever the smallest number is that all of the denominators can divide into, that would be the least common denominator. Okay, so since we figure out what the least common denominator is, now we're going to multiply every term times the least common denominator. So we're going to multiply every term times 28. Okay, so instead of multiplying and then dividing, it's easier if we go ahead and reduce each fraction, and we can do that in the first term. 4 will go into 28 7 times. So now I don't have a denominator. This is like a 1, so I don't have to write a denominator. So this would be 7 times x minus 3 equals, okay, so now in the next term, 14 will go into 28 2 times. So I'm left with 2 times 5. Minus, in the last term, 7 will go into 28 4 times. Okay, so I have 4 times x plus 5. Every time we have a term that is more than just a single number, make sure you put it in parentheses, because like that x plus 5, it's going to need to get multiplied. Each term in that binomial will need to be multiplied times negative 4. The same thing in the first term. In the x minus 3, the x and the negative 3 both will need to be multiplied times 7. So make sure that you put the binomial in parentheses. So now we have a linear equation, no more fractions. So we just solve this like we would any linear equation. The first thing I'm going to do is distribute to get rid of the parentheses. So that's 7x minus 21 equals 2 times 5, which is 10. Now I need to distribute the negative 4, so that's minus 4x minus 20. Okay? Now I want to combine any like terms. Well, the only like terms are on the right side of the equation. That 10 and negative 20 are like terms. So if I combine these two, the 10 and the negative 20, then I get negative 10 minus 4x. Okay, so now I want to get my x's on one side and my stuff without x's on the other side. Okay, so I'm going to add 4x to both sides of the equation. Alright, so that gives me 11x minus 21 equals negative 10. Okay, so then I'm going to add 21 to both sides. And that gives me 11x equals 11. Divide by 11, and x equals 1. Okay, I'm not going to take the time to check this, but if you wanted to check your solution, then you would just need to go up here and plug 1 into both of those spots where the x's are and simplify. Alright, here's another rational equation. And the least common denominator in this rational equation, first of all, we have to include every separate factor. So in these terms, we have numbers and we have the variable x. So the variable x is a separate factor. So we know that that needs to be included in our least common denominator. All right, so our least common denominator we know is going to have an x. All right, let's figure out what the number is that's going to go with that x. Okay, so the biggest number is 18. Will 3 and 2 divide evenly into 18? Yes. So 18x is going to be my least common denominator. All right, so that's what I need to multiply every term by, 18x. And like I said, we need to reduce before we multiply. So if I reduce the 2x and the 18x, well, the x's cancel, and 2 will go into 18 9 times. So the only thing that's left is that 9, and I'm going to multiply it times 5. So 5 times 9. All right, in the next term, that 18's cancel, but the x didn't cancel, so what's left is 17 times x, which is 17x. In the last term, the x's cancel, and 3 will go into 18 6 times. So I have a negative 1 times 6. Okay, so if I simplify that, I get 45 is equal to 17x minus 6. So now I need to get my like terms together. Okay, so I'm going to add 6 to both sides of the equation. So that gives me 51 is equal to 17x. Divide both sides by 17, and 17 will go into 51 3 times. So x equals 3. Now, one thing that you need to be aware of when you're solving rational equations is your solution cannot cause your denominator to be 0. So always be aware when you look at your original equation, be aware of what the excluded values are. What I mean by that is what values of x would cause your denominator to be 0. All right, so here this denominator has an x and this denominator has an x. Well, the only thing that I could plug in for x that would make that 0 would be 0. In this equation, or this term, if I plugged in 0 for x, 3 times 0 equals 0. So if I plugged anything else in, it wouldn't make it be 0. If I plugged in 3 times 3, that would be 9. But if I plugged in 0 for x, that would give me a 0. The same thing in the other denominator. If I plugged in 0 for x, 2 times 0 would be 0. And so that is, 0 is the only value of x that would cause the denominator to be 0. So that's something that you need to be aware of, because if we had gotten 0 for our solution, we would have to say that there's no solution, because the solution would cause our fractions to be undefined. But that's not the case here, but that is something that you need to be aware of. Okay, let's try another rational equation. In this, like I said, we have to include every separate factor. Well, in this equation, x minus 2 is a factor, x minus 2 is a factor, and 3 is a factor. Okay, so we only include each separate factor the maximum number of times that it shows up in any one term. So like if I had an x minus 2 squared, in our least common denominator, we would use x minus 2 squared. But since the most number of times that it shows up in any one term is once, x minus 2, then we only use x minus 2 once in our least common denominator. So our least common denominator is going to be x minus 2, but then we also have to include that 3 because it's different than the x minus 2. So we use every different factor in our denominators. Okay, so let's multiply every term by the least common denominator. 3 times x minus 2, 3 times x minus 2, and 3 times x minus 2. Okay, so in our first term, the whole x minus 2 cancels, and I'm left with the x times 3. So that's 3x equals, in the second term, the whole x minus 2 again cancels, and I'm left with 2 times 3, which is 6, minus, in the last term, the 3's cancel, so I'm left with 2 times x minus 2. Okay, so let's simplify that. I need to distribute that negative 2 into the parentheses, so that gives me a negative 2x, a negative times negative, that would be plus 4. Okay, so if I combine my like terms, 6 plus 4, that's 10, minus 2x. Okay, so then I'm going to add 2x to both sides. So I get 5x equals 10. And then I divide both sides by 5. And I get x equals 2. Okay, so remember I said that we need to be aware of what our excluded values are. Well, if I look back up in my original equation, we don't care about the numerator. There's an x in the first term in the numerator, but that doesn't matter because we can have a 0 in the numerator, and that does not cause the fraction to be undefined. But if I have a 0 in the denominator, it will cause the fraction to be undefined. So that's all we care about. Well, this denominator doesn't even contain an x, so we don't have to worry about that. But the other two denominators, they're the same, and it's x minus 2. So what could I plug in for x that would make that 0? If I were to plug in 0, 0 minus 2 would be negative 2. And that's okay. We could have negative 2. But if I were to plug in where the x is, if I plugged in 2, 2 minus 2 would be 0. And that would make our denominator or our fraction undefined. So we can't get 2 for an answer. Well, that's what we got. So that means we have no solution. In our equations, we can have some different types of solutions. An identity is an equation that's true for all real numbers. Both sides must be defined. So the equation that we just looked at was undefined because we didn't have a solution for it. But when we get when we work out our equation and both sides of the equation equal each other, if our variables cancel out and both sides equal each other, for example, if we were to work it out and we didn't have any variables left and we got an answer like 2 equals 2 or -7 equals -7, that would be an identity because it's a true statement, okay? And that means we could plug in any number for x and it would be true. A conditional equation is an equation that's not an identity, but it's true for at least one real number. So that's what we usually get. A conditional equation is when we get an answer like x equals 5. So if our variables don't cancel out and we get a value for our variable, like x equals 5, x equals 0, x equals 9, that would be a conditional equation. An inconsistent equation is an equation that's not true for even one real number. The lack of a solution is represented by the empty set 0 with a slash through it. Okay, so that would be if our variables cancel out and we get something like 2 equals 9 or -1 equals 0. Whenever we work it out and it's not a true statement, our variables disappear and it looks like this. That's called an inconsistent equation, and we have no solution. So here is an example of an equation, and we are to determine whether the equation is an identity, a conditional equation, or an inconsistent equation. Okay, so I'm going to rewrite this. Okay, and to solve this, the first thing we want to do is get rid of the parentheses, so we're going to distribute. And that gives me 4x minus 7 equals 4x minus 4 plus 3. Okay, so then we want to combine like terms. And on the right side, the -4 and +3 are like terms. And when I combine those, I get a -1. Okay, so then I want to get my x's together. I'm going to subtract 4x from both sides. But when I do, that cancels out 4x on both sides of the equation. And I'm left with -7 equals -1. Well, that's a false statement. So if I get a false statement, that means that this is an inconsistent equation. And I have no solution. If I had gotten -7 equals -7, a true statement, then that would be an identity, and I would have infinitely many solutions. If I had gotten something like x equals -1, that would be a conditional equation, and 1 or -1 would be my solution.